Okay, so the general solution for going from a difference equation to the general form. Okay, I'm assuming the geometric sequence or both? Both. Okay. So let me start with the arithmetic sequence, possibly because it's a little bit easier. Start to go back to the pen. Yeah. Okay. So the arithmetic sequence, the difference equation here is x n plus 1 equals x n plus b. So I'm increasing or decreasing, depending on whether b is positive or negative, by a fixed amount. And this just tells us what's happening in the next generation based on the previous generation. So that's the difference equation form. So if I want to look, I always start at some x naught or x sub 0, okay? And if I want to look at what happens in the first population, then that's x naught plus b, right? If I want to know what happens in the second population, then that's x1 plus b. Now, x1 is the same as x naught plus b, right? Okay? And then we have a plus b. So altogether, what happens in the second generation is I have x naught plus 2b. Okay? Now let's look at the third generation. Well, that's x2, the population in the second generation, plus b. What is the population in the second generation? It is x naught plus 2d plus b. Okay? Simplify. So let's look at this very quickly. X naught is the population in the 0 generation. In the first generation, the population is x naught plus b. In the second generation, the population is x naught plus 2d. In the third generation, the population is x naught plus 3d. And can we guess what the population in the fourth generation is going to be? X naught plus 4d, right? And we could do another iteration out, but what happens is that this is the third generation is x naught plus 3d, and then we're going to add another d. So we essentially get x naught plus 4d. So in the nth generation, so that's the general form, we get some form for the nth generation. In the nth generation, we get x naught plus nd. And that's the general form. Okay. So the differential equation form has n plus 1, x sub n plus 1 in terms of x sub n. The general form has a function in terms of n. Okay? And most likely your starting position and then another parameter. Okay, now we can talk about what happens for the conversion to the general form for arithmetic sequences. Sorry, for geometric sequences. So geometric sequences look like x n plus 1 equals r times x to the n. Okay? Let's do geometric. Sequence equation. Okay? And we can do the exact same thing. We start at x sub 0. X sub 1 is r times x sub 0, right? So Okay, so in the second generation, it's R times the population in the first generation. The population in the first generation is R x of 0, right? So I just simplify now. R times R is R squared times x of 0. Okay. Now we go to the third generation. In the third generation, I'm R times the population in the second generation. Well, the second generation can be expressed by R squared x naught. Well, simplification, R times R squared is R cubed. So we see a similar pattern starting to emerge here, where we can now guess that Xn is going to be Rn x of 0. And there are actually proofing methods to prove that this is true, but it's fairly obvious. I think we can kind of jump there without too much problem. And then this is the general form for geometric. Okay? R is one way of calling it. R is a reproductive rate, but it really just tells you the ratio that will be around in the next generation. Sometimes if that ratio is bigger than 1, then it means you're growing or increasing. If that ratio is less than 1, then you're decreasing as a population. It's sort of like a survivorship. Any other questions about homework or anything else?